Dude, I had a good week.
223 out of that. They're already 1 point.
You still won it, right?
Yeah.
There's like Woodstock.
And then 276.
Look at this.
748. That's where it's at. 248.
42 points. Yeah, because Cam got -30.
Yeah, I started to progress a little bit.
Oh, I got so close on this one, man. I won by 0.2.
So we're going to just cycle through some of the topics that we've touched upon from last Friday and from yesterday, just so that we're just getting more reps with what to expect on the test. So if we can look at test review worksheet 1 from yesterday, and then we can, I'm just going to pick out some problems I think are good for us to go through. So we'll do this from worksheet 1 first, then we'll move on to a worksheet 2 review problem. So number 1 says find the equation of the line tangent to our graph at x equals -1. So let's step through the process, the big idea here, and then I'm gonna have you guys try it, and I'll just kind of come around and see how you guys do. So if I want to find the tangent on the equation, I need ordered pair. I need a slope, and then I can put in the point slope form, right? So that's how I'm going to progress through this problem. So how do I find the ordered pair?
Just plug it into the original.
Yeah, into the original, right? No derivatives involved. We're just taking the x, plugging in, find the y. Okay. To find the slope, we'll have to first find the what? Derivative. Okay. So look at how this is set up. What's involved to find a derivative? Quotient rule. Yeah, quotient rule. Right. And I have rules up there on the board, right? We have a rule for e to the u. We have a rule for x squared. And after you find the derivative, then we can move on to find the slope by doing what?
Plug it into the derivative.
There you go, right? You got the slope formula, and then use the x value to find the derivative. And then once you have your ordered pair and you have your numeric slope value, then point slope form. Okay, all right, try that. See how far you guys can get. So there's my ordered pair. Use quotient rule to get to your derivative. Don't forget the other part of the quotient rule, right? Divided by g squared. Okay, so here's my derivative function. F prime times g minus fg prime all over g squared. I cleaned up my derivative a little bit, and then from here, I can involve -1, right? Plug -1 into the derivative, and that's going to get me down to a numeric answer and a numeric value, and that's going to represent the slope. Any questions up to this point? Start replacing all your x values with -1. I'm able to get it down to like terms here. So 2 plus 2 is 4. 4e to the -2 is 4 over e squared. Ordered pair from the original function, slope from the derivative, and then finally point slope. Okay, any questions here? Okay, I'll leave this up here for another minute for those who need to look at this. But we're going to move to, yes, question.
What were just on the last section here without the slope?
Oh, right here.
Yes.
So I replaced all the x's with -1. So I get 2 times -1 squared times e to the -2 minus 2 times -1 times e to the -2. The -1 squared becomes just positive, so that leaves me with just 2e to the -2. And here, the two negatives become positive, so I get 2e to the -2. The denominator just goes away, it's just 1, so I get 2 plus 2 is 4. And then I clean it up to 4 over e squared. And then my order pair and my slope, y minus y1 is equal to m times x minus x1. Sam, did that answer your question? It did? Okay. Okay, anything else with 1? Okay, let's go to number 1 on worksheet 2. Are we good here? Anybody still need to look at this? Okay, worksheet 2, we're given a position function. And we want to find the velocity function. So we have to find the derivative to get from position to velocity. And from velocity, we're going to find the derivative again to get to acceleration. Now the answer is provided for us. So we just want to show our work and see if we can make our derivative for position look like our velocity function. Okay. So we're starting with a position function. What's involved here to find the derivative? Quotient rule. Okay, so we start with quotient rule. So go through quotient rule, clean up your expression, and your answer should be able to clean up to this. Okay, so see if you can go through those steps. And once you get to the velocity function, we should be able to apply the same process, right? Quotient rule again, velocity to acceleration. And then from there, we're just going to go down the first column. We're going to do C, E, G, and I. All right, let's see how you do. let me show work for velocity. Now we need to make our way down to acceleration. So first up, velocity. F prime g minus f g prime all over g squared. If I combine like terms, I'm also able to factor an e to the t out. Now denominator has e to the t squared, so technically that just means that we have two e to the t's. One of them can go away, and we're left with 2 minus 2t over e to the t. Yes?
Why is G prime e of t?
Right, so the reason why is because we're following this rule here, right? So the rule for e to the t is e to the t times t's derivative, and t's derivative is just 1. So yeah, so this exponential function, the reason why it just works so nicely with calculus is because the function, the derivative is the function, and so that kind of allows for a lot of clean relationships for exponential function for our purposes of calculus. So yeah, so technically this is times 1 here, but it just doesn't change, that's why. Okay, are we good with velocity here? So from velocity, we get to acceleration. Again, we do quotient rule, f prime g minus f g prime all over g squared. Distribute the negative 2 through and multiply with e to the t. We see some like terms there. Combine like terms, factor out e to the t. Again, one of the e to the t's can match and go away between numerator and denominator. Any questions there? Let's look at the rest of the worksheet. We're just going to go down that first column there, go down looking at part C here. Okay, so part C says for what values of t is the particle at rest? So how do we approach that? How do we find when the particle is at rest?
Set the derivative equal to 0, so velocity function.
Good, velocity. So velocity equal to 0, right? Particle at rest, another way to say that is when velocity is 0, right? But my velocity has both numerator and denominator, so what do? Do I look at both? Do I look in both locations?
Well, just the numerator, because
Yeah, it's going to be just the numerator. Why not the denominator?
the denominator means undefined.
Yeah, that means velocity is undefined, right? We want specifically slope velocity to be 0, not undefined. So there's a distinction there, right? We're looking for at rest. So we don't want when the particle is on the when the velocity is undefined. We want when velocity is 0. Good. So just the numerator. Okay, so we set 2 minus 2t equal to 0. We solve for t. We get t equals 1. Okay. All right. Any
Mr. Yang, I have a question.
Yes, question?
Back to the acceleration one, actually, why is f prime -2 and not 2? Or -2 times e to the t instead of +2?
Let's see. Are you talking about the velocity or the acceleration function?
Acceleration.
Acceleration. Okay. What about the acceleration?
Why is f prime -2? Instead of,
The reason why is because we're starting with the velocity function, right? So we're doing f prime g minus g prime. So 2 minus 2t's derivative is going to be -2. Were you looking at the acceleration function?
oh, yeah, I was looking
Yeah.
at that.
So we're not starting with this. We want to end up here. We're starting here, so
Okay.
and then moving from here to here.
Okay, thank you.
We're trying to show that's our answer. Okay. Part E. For the value that we found from part C, which we found was t equals 1, is the velocity increasing or decreasing? So how do we determine increasing, decreasing velocity? Where do we look?
Velocity sign one.
So this is, the wording is a little, it's a little misleading, right? It's not actually talking about velocity. This is actually talking about what? You see that word increase, decrease? It's talking about the rate of change of velocity. So without saying it, it's telling us to look at acceleration.
So the values are different.
Uh,
Acceleration is a different sign than velocity.
That's something else. That's something else. Here, we're just talking about velocity increase, decrease. So we're going to just look at acceleration. If acceleration is positive, then velocity is increasing. If acceleration is negative, then velocity is decreasing. So, right. So I want to make sure that we understand those distinctions here. So, what can we find then? What's the sign of acceleration at t equals 1? Positive or negative? Negative, right? So therefore, velocity is decreasing. Okay. If you see this problem on the test, I'm also going to ask you to give me justification, to give me a because statement. So you would say velocity is decreasing because good. Acceleration is less than 0. Okay. I'm looking for justification as well. Any questions there? Okay, for G, what is the velocity when acceleration is 0? This is a two-step process here. What information should we look for first, or how should we begin this problem?
So we should set the acceleration equal to 0.
Acceleration equals 0. That will help us find the time. And then once we have the time, then we can use that t value to into the velocity, right? Now acceleration is, again, numerator and denominator. We want to find when acceleration is 0, so we look just the numerator. Okay. So we take the numerator of acceleration, set equal to 0. We solve for t. Now we have this moment in time that we can use to help find the velocity. We get -2 over e squared. Okay. Any questions there? For part I, at t equals 3 is the speed of the particle increasing or decreasing. So this wording looks a little different from E, but or looks similar, but a very different process here. How do we determine increasing, decreasing speed?
So this was the different side.
Yeah. So can you elaborate?
So if velocity is positive and acceleration is negative, then it would be decreasing speed and then inverse, vice versa.
Okay. What about increasing speed? What would need to happen?
The same sign.
Same signs. Good. All right. So determine increasing, decreasing speed. We compare signs between velocity and acceleration. If acceleration and velocity are the same signs, then increasing speed. If velocity and acceleration have opposite signs, then we have decreasing speed. So let's do that. Let's find acceleration at t equals 3. Let's find velocity at t equals 3. Look at the sign of the results that we get, and from there we can make our conclusion. And again, if you see this problem on the test, you're going to have to provide your justification. You have to write your because statement. Okay, what do we find?
The signs differ. It is increasing.
Yeah. Okay, and we'll have to say because velocity and acceleration have opposite signs. Right? All right, any questions there? Okay, I'll leave this up here for a second, but if you're done, let's go to the back, and we're going to look at number 2. The natural log problem here. Okay, so natural log of xy squared is equal to y squared minus 3x. Find the derivative. Okay, anybody still need this? Guys good? Okay. Number 2. Natural log of xy squared is equal to y squared minus 3x. We want to find the derivative. Let's point some things out. What process is involved here?
Implicit.
Good. Implicit. You have y's all over the place. It's kind of mixed into the equation. Good. What else?
Product.
Product what?
Like ln x plus ln y.
Okay. Right. So before we do our derivative, right, we can actually do something to make our derivative process easier. We can go through expansion properties. Okay. All right, so try that. Let me show the properties for you guys. So expand the left side as much as you can. And then once you have everything nicely separated, then you can explore the derivative rules for each term. Yeah, whenever you're asked to find a derivative and you see log or natural log involved, always consider, is there any expansion that I can do? Doesn't mean that you're always going to be able to expand, but we always want to look for it, because otherwise our derivative is going to be too messy, too complicated. No, just
oh, yeah. Oh, yeah. Well, it's.
let me show the full expansion step before you start your derivative process.
Oh, I think you said yeah, we got this. Yeah, we got this.
So that is how far we can expand. Notice that now we have 4 individual terms, and these are all relatively easier for our derivative step, right? The 2 left terms, we can apply u prime over u, and the 2 terms on the right, we can apply power rule. But then we got to keep track of our implicit, right? We have our y terms there, so each of those y derivatives will produce a dy dx. U prime over u prime over u with the dy dx attached. Y squared is power rule, but with dy dx attached. Any questions so far? So calculus steps end here. Now we're just trying to get dy dx by itself. So keep the dy dx terms on the left, move the non-dy dx terms to the right, factor dy dx out. You can leave your answer in complex with complex fractions, that's okay. But if you find common denominators and clean up, it will look like this. Okay. Any questions, any parts you want me to clarify or to go over? Yeah.
So earlier, before you solved it, you had natural log y squared just below, and then put 2 in front. Did you use power rule?
We use something called power property. So once we're inside a natural log expression, we can bring that exponent down without changing the overall value, but sometimes it makes things faster and easier to evaluate. Yeah. So we have these 3 properties available to us.
Okay.
Yeah. Okay, good. Anything else? All right, let's practice a problem where we have to use some of the newer rules that we learned, log base a and a to the u. So I just created this first period, so it's not on your worksheet. So if you guys can put this down somewhere here. Yeah. Are we good with 2? Anybody still need to look at that? No. Here's number 3. Let me show rules here. So we have to involve some of these new rules here. Okay, so I want us to think about a few things here. Obviously, we have to use the rule for a to the u, which is natural log of a times a to the u times b prime. Log base 5, we have a specific rule for that as well. But what else is involved? What other process we have to be aware of? Product rule, right? Product rule. Okay, so f prime g plus f g prime, that's our derivative process. We can't just find each of their derivatives and just end there, right? We gotta kind of go through that product rule process. And the second thing I want to point out is, do we have any expansion opportunities on this side with just this log term?
Well, you could put e to the 5x over x cubed.
So here's the thing, is that if it doesn't look exactly like the rules that's available, then we're not able to move forward. So if you look, right, we don't have a rule for log of a minus b or log of c minus d, right? Now, if e to the 5x and x cubed, if they were together, if they were being multiplied or they're being divided, then I can expand them out into log of the two terms added or log of two terms subtracted, right? But I want to point that out because I think the tendency is we may look at that and think that it's expandable, right? But it's not. So it's a very subtle difference, but we can't expand that. Or maybe you're thinking that I can just distribute the log base 5 through, right? But that e to the 5x minus x cubed is inside the log expression. And so it's kind of stuck in that form. We can't do any expansion, even though it looks like we can, right? And also, it doesn't match any of these setups, right? If it doesn't match these setups, we can't create our own property. Okay, so we're going to jump into our derivative rule. So see if you can use these rules to help you set things up. And we got product rule going on here, right? All right, try that. Put this up here. Your derivative will look like a mess, but you just leave it all unsimplified. I just want to see if you can represent the derivative within product rule and know how to read the rules and know how to apply those pieces. Okay, let's see how you guys did. Notice that when I get to this part here, log base A becomes 1 over ln of A times u prime over u. Looks a lot like natural log u rule. But within my u prime, I got to find the derivative of each of these terms, and the rule for each of the u is e to the u times u prime, so it's e to the 5x times 5. Okay, so we're just following along the rule, right? If you can match the parts of the rule, you're just kind of doing whatever the rule tells you to. Okay. Any questions with any of those parts? Okay. So tomorrow we can kind of revisit some of the things that maybe we haven't seen in a while. Maybe we'll do another um, finding relative max, relative min, POI, first derivative and second derivative sign lines. Maybe we'll do a log differentiation problem. Do more derivative rules where we need to go through expansion. And I'll maybe go over some of the common mistakes that students have made. That's on that document that's under yesterday's worksheet. Okay, so we're just kind of revisiting some of these topics, and hopefully you're just feeling more comfortable with these test topics coming up. A couple reminders. Tomorrow is the due date for the recovery assignment, so look over the Teams assignment. I'm looking for you to turn in through Teams your homework, classwork, textbook problems, and test corrections. Okay, and then you're also going to let me know when you turn that in whether you're going to want to take the recovery test on Friday, 7:15 or 4:30 p.m. and it's going to be on Teams. Okay. I'm having help sessions for test review, second half of 5th period, before school and after school, 7:30 and 3:30. Okay, so I'm recording all those sessions, but if you want to come in or if you want to join on Teams, feel free to do that. All right. Any questions? All right, if you're on Teams, free to go. Have a great day. See you tomorrow.
I'm going to say Mr. Yang.
Have a good day. See you guys.
Thank you.
Bye.
Mr. Yang.
Yes, question?
Mr. Yang. Yeah. Do you have like a list